Let's say that you have a beautiful vegetable garden, but you're in the middle of a drought and the only source of water at your disposal is this 1,000-gallon hot tub. Now let's ignore the chlorine and other chemicals in the water because remember, you're desperate. You begin by only needing 1 gallon of water a day, but that rate is going to increase exponentially by doubling each day. So on the second day, you're going to need 2 gallons, and then 4, and then 8, then 16, and 32 gallons. Let's take a look visually what happens to the amount of water in the hot tub each day as time goes on. You start out with a full hot tub, and on day 1 you remove 1 gallon, and then 2 gallons, and then 4 gallons. It seems like you're hardly using any water at all. Even on day 6 you have over 900 gallons left in the hot tub. By day 8 you have 3/4 of the water remaining, and then half the water remaining. By day 10 it's all gone. How did that happen? How did you go from hardly using any water at all in the beginning to using 75% of your entire resource in the last 3 days? It turns out that that's one of the consequences of exponential growth. You can tell by the shape of the graph that the slope or the steepness starts out gradual and then gets much steeper as time goes on. Let's take a look at the same scenario with the same information, but this time we'll graph the amount of water removed from the hot tub as time goes on. The amount of water will grow exponentially by doubling each day, just like it did before. Now we're looking at how much water has been removed from the hot tub each day. As we saw earlier, even though the amount is doubling each day, it doesn't appear that much is happening in the beginning. By day 8, we've used up 1/4 of our resource. By day 9, we've used up half the water. By day 10, we've used up all the water. There's nothing left. This data table shows one of the most important consequences of exponential growth. You remove 16 gallons on day 5 alone, but prior to that the total amount removed was only 15 gallons. And you removed 512 gallons on day 10 alone, and prior to that the total amount removed was only 511 gallons. So the growth during any doubling time will be greater than the total of all the preceding growth. But what if you still need to water your garden? That was just a small hot tub. What if you had access to a much larger resource, like let's say every lake, river, ice cap, and ocean on the entire planet? Ignoring the fact that putting salt water on your garden would just be a bad idea. But surely a resource of this magnitude would now be sustainable, right? We're going to just skip to the end here because I don't want to bore you with the beginning part of exponential growth when it appears that not much is happening. So after 61 days or doubling times, it looks like not much water has been used. In fact, at this point, less than 1% of the water on the planet's been consumed, and you can hardly see it on the graph when the y-axis is set to include the 150 quintillion gallons of water on the planet. After 63 days, only 3% of the water has been consumed, and most people would probably think that the water would continue to last for a long time. After 64 days, that doubles to about 6% of the water. After 65 days, only 12.5% of the water on the planet has been used. After 66 days, only 25% of the water has been used, but hey, you still have 75% left. After 67 days, half of the water on the planet has been used. There is still as much water left as has been used in total since you started using this resource, so you should still have at least another 67 days left, right? Well, after only one more day and another doubling, 100% of the water on the planet has been used. It's all gone. You started by only using 1 gallon of water per day, and after a mere 68 doublings have managed to consume every single drop of water on the planet. If you ask me, that is one crazy consequence of exponential growth. Exponential growth leads to rapidly depleted resources. Only 4 days before all the water on the planet is gone, 94% remained. So may this be a lesson to us. If our consumption of any finite resource is growing exponentially, like at 3% per year, and we've only used 6% of it, we only have 4 more doubling times left of that resource. When 25% has been used, only 2 more doubling times are left, and when half has been used, only 1 more doubling time of that resource remains. So what finite resources are we consuming at exponential rates? Well, there's oil, coal, natural gas, essentially all of the major energy sources that we rely on. Population growth, water consumption, food production, and mineral extraction are all growing at exponential rates, and none of this is sustainable.